Hey friends, it's Miss Adams again from Flamingo Math. We're in the third day on talking about vectors. In today's lesson, we're going to explore the ways vectors can get multiplied. That process is called the dot product. It results in a scalar. Here's the language for dot products. If you have vector u with two components and vector v with two components, to get the dot product, that doesn't mean just multiply them together. That means to multiply the first components, multiply the second components, and then add them together. You'll get a scalar from that process. These are the properties of vectors, of products, properties of dot products of vectors, and we'll jump right in finding the dot product of u dotted with v. So if u is 512, u dotted with v is going to be 5 times -3 and 12 times 2. Then we're going to add the two products together. So -15 plus 24 gives us u dotted with v, the scalar of 9. The dot product is a scalar. A scalar is a real number. We want to use the dot product to find the magnitude of u. So that dot product back here, if you dot one vector with itself, you get v squared. So we're going to do that with example 12. The magnitude of u is going to be squared. It's u dotted with itself. So u squared is 2 times 2 plus -4 times -4. That's 4 plus 16. 4 plus 16 is 20. And if you take the square root, you'll get the square root of 20 and the magnitude of u, because this is the magnitude squared. So u is 5 times 4. The square root of 4 is 2. So the magnitude would be 2 square roots of 5. In example 13, we're talking about orthogonal vectors. Now, what is an orthogonal vector? It's a perpendicular vector or normal vector. The word normal and the word orthogonal mean perpendicular. So orthogonal vectors have a dot product that's 0, and we want to show that vector u and vector v are definitely perpendicular to each other. We can do that by dotting u with v. U is let's look at component form. U is 2, -1, and v is 3, 6. So if we dot u with v, our product should be 0. 6 minus 6, u dotted with v, is definitely 0. When the dot product is 0, vector u is perpendicular to vector v because the dot product is 0. So we proved that using the properties. Sometimes we need to take a vector and break a vector down into individual components. Vectors are comprised of the horizontal component and the vertical component. You can use the special unit vectors I and j to help us find those individual components. The linear combination where a and b are respectively the horizontal and vertical components of the vector is given by a I plus b times j. A unit vector is simply taking the length of the vector and dividing it by the magnitude of the vector. The I represents the unit vector on the x-axis, 1 unit right and nothing up, and the j is the direction on the vertical axis, no units right and 1 unit up. Let's try example 14. We want to find the components of vector v if the initial point is at 4, 2. So 4, 2. Whoop, that's an eraser. I need a pen. The initial point's at 4, 2. And the terminal point is at 8, 4. So we want to go, if you think about it this way, we want to go vector v is 8 minus 4. So 8 minus 4, that's the first components. And then 4 minus 2, so 4 minus 2. And if we do that arithmetic, we have 4, 2. So 4, 2 is the component form. The linear combination form for vector v can be written as 4 in the I direction and 2 in the j direction. And this is vector v that's been moved. Vector v. And to show you what that means, we went 4 in the I direction. This is the I axis. And in the j direction, 2 in the j direction. And you can see the parallelogram method that we've added those two together to get that terminal point at 4, 2. For example 15, can you find the unit vector in the same direction as 3i minus 4j? So let's first draw an xy coordinate system here. This is in the x direction, this is in the y direction, and we've got the terminal point at 3 units right and 4 units down. So this is our terminal point at 3, negative 4. That's the component form. We want the unit vector. So I want to know if I divide this unit vector up, think about that Pythagorean right triangle here. This side is 3, this side is negative 4, the hypotenuse is 5. So we know the magnitude of vector v is 3 squared plus negative 4 squared. So our magnitude is 5. The unit vector, to find the unit vector, we're going to take the components of the main vector, 3, negative 4, and divide it by 5. So u can be rewritten as 3/5 in the I direction, that's horizontal, and 4/5 in the j direction, but that's supposed to be minus because this is minus negative here. In the j direction, what does that look like? Vector u is 3/5, negative 4/5 in component form. That means if we go out 3/5 and go down 4/5, that's our unit vector right there, that little bitty one. That's the unit vector. There are 5 of those. We could cut and paste this 5 times to get out to the end. Takes 5 of those unit vectors to cover that space, 5. Example 16. If the wind is blowing at 15 miles an hour in the direction northwest at pi over 3, express its velocity as a vector and then round your result to the nearest tenth. So you need your calculator here to help me out. We have the magnitude. We're told the magnitude is 15 miles per hour. We know that the angle is pi over 3. And if you think about it going in the northwest direction, so let's think about that visually here. Magnitude is 15. So we have this length 15. The angle from north let's see, this is north, this is west. So the angle in here is pi over 3. Drop a perpendicular back down to the x-axis. This angle in here has to be pi over 6. So the theta prime, if I called this angle from here, from the x-axis over to the vector, if that's called theta prime, that would have to be 5 pi over 6. Now, we were told we could find the components. This is where you need the calculator. The A component is the magnitude times the cosine of our theta prime angle, 5 pi over 6. So help me with your calculator. I'm getting 12.990. And then our B component is the magnitude times the sine of our theta prime angle. That's 7.5, because 5 pi over 6 sine there is a half. That means we have vector V can be written, I'm going to round this to the nearest tenth, as negative 13.0 in the I direction and 7.5 in the J direction, and our units are miles per hour. Okay. Next, we're going to explore finding the angle between two vectors. So we have two formulas. There's the basic formula that says if you want the cosine, if you want to find the angle between two vectors, we can do that by taking u dotted with v divided by the product of the magnitude. So these two on the denominator, that's multiplication. And this number is the cosine of our angle. So if we want the angle, we would use the inverse properties of cosine. This is the alternate form. It's basically just the same thing, moved around with a little bit of algebra. So let's suppose we have, in example 17, we have vector 2i minus j. So that vector is terminated at 2 on the x-axis and negative 1 on the y-axis, because I represents the horizontal and j represents the vertical. Then vector v is located at 6, 4. So component form 6, 4 is out here. And what are we looking for? We're looking for the angle between those two vectors. What is that angle measurement? So we know what the rule is. Let's write the rule again, since this is new to us. The rule says the cosine of the angle is the dot product of the vectors u dotted with v, u dotted with v, divided by the product of the magnitude. Okay, let's give that a go. So the cosine of our angle is the x-coordinate times the x-coordinate plus the y times the y, and the magnitude is the square root of 2 squared plus negative 1 squared times the square root of 6 squared plus 4 squared. Those are going to be some, let's see, 12. We got 12 minus 4, and then 4 plus 1, that's the square root of 5. That's not bad. 36 plus 16 is 52. So the cosine is 8, and 5 times 52 is 260. So we're looking for the angle, the cosine inverse of 8 divided by square root of 260 little caution here. Check your calculator that you're in radian mode. If you're not in radian mode, you're going to get the wrong answer. And we're going to find out that the angle is 1.052 radian. So a little around 60 degrees is the angle there, 1.052 radians. Then the end here, we're going to go use law of sines and cosines. I believe this is something that's not tested on the AP exam, but it is something that is used for practical applications. And there's two laws that give us a chance to use trig functions on oblique triangles. Now, an oblique triangle is like angle, side, angle, 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 side, side, angle, side, 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 side. But side, side, angle, that's called the ambiguous case. Let's make a note of that. This is the ambiguous case. And you may remember this from geometry. It could result in a triangle that has one solution, two solutions, or no solution at all, where you can't make a triangle because one side is too short. So you had one really long side and another side, and you knew some angle, and the angle was up here. This side was so short you couldn't make that triangle possible because it couldn't be extended down. Also, on the law of sines, the law of sines is given using this triangle here, and the sine of the angle over the opposite side, so angle alpha divided by its opposite corresponding side, and the sine of beta divided by its corresponding side, and the sine of C divided by its corresponding side, those have to be equal to each other. That's called the law of sines. And the law of cosines, if you need a side, you use these formulas down the left-hand side. But if you need an angle, you can manipulate this formula by isolating cosine, and you can use the formula this way. Techniques for solving. We want to find if you have a side, 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 and using the law of cosines, you want to find the angle opposite the longest side first, and then use the law of sines to find the missing angle. And then you can find the third angle by adding up the three angles to equal 180. So let's give that a try here. We want to find the side. Let's see, it's a vector application. And then these are the steps for using a side angle side triangle. We'll come back to that in a minute. I believe we have 2 or 3 examples to try those with. So let's say we have 2 airplanes that leave an airport at the same time on different runways, and one of them flies directly north, and he's flying at 420 miles per hour. So flying due north at 420 miles an hour. The other airplane flies on a bearing of 5 pi over 12 at 375 miles an hour. So if this is the airport here, recall that the bearing is the angle that the line of travel makes with the north, measured clockwise. So we're going to use the law of cosines. And Their airplanes are going to be flying for 2 hours. So one of them, 420 for 2 hours, means he's traveled 840 miles. And the other one, 375, means that airplane has gone 750 miles. And we want to know how far apart they are, that distance right there. So what kind of triangle is that? Side, angle, side. This is a side, angle, side triangle. So that formula is law of cosines. 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine of the angle between them, 5 pi over 12. That was our angle. So you need your calculator. Being very careful to calculate all of those. I get 970.5 miles. So therefore we know that the airplanes are about, we're going to round up to the nearest whole mile, 971 miles apart. So that wasn't so bad. Example 19, we got 2 more to go. A DC-10 jet is flying on a bearing of pi over 3 at 500 miles per hour. So we're going to draw that picture. This is north, and this is east. And we're going out here, and our bearing is pi over 3 at 500 miles per hour. So that's the magnitude there. This angle here, theta prime, is pi over 6. So bearings are measured from north clockwise. Okay, so we've got, I'm going to call it vector z, is the magnitude of the cosine of theta in the I direction plus the magnitude of sine of theta in the j direction. So what's our magnitude? That's 500. And our angle is pi over 6 I. Magnitude, sine of pi over 6 j, because we're using the theta prime angle with trigonometry. And again with your calculator, 500 times cosine pi over 6 is 433.01 in the I direction and 250 in the j direction. And I'm kind of out of space to write, but what that means is that the plane is traveling 433 miles per hour in the east direction and 250 miles per hour in the northward direction. But it's traveling on a bearing of pi over 3 at 500 miles per hour, which we had here. And then the last example for this section, oh no, I take that back. Oh yeah, it must keep going. Find the magnitude and direction. Let's see if we have room to do it down here. Of the sum W of 2 vectors U and V with magnitude 6.9 and 13 respectively. So we're going to draw a parallelogram. Okay, so we got a vector here, U is 6.9, and a vector here of V, that's 13. And what do we know? The angle between them measures pi over 4. So this angle is pi over 4. And we want to add up, make that parallelogram, because the resultant is the vector W. And that goes from here, where it started, out to here. This is W. So what else do we know? We know this angle has to be 3 pi over 4. Okay, so first of all, we have the parallelograms, P-A-R, A-L-L-E-L. We got a parallelogram angles have to sum to 2 pi. So we know that we have 2 pi over 4 angles, and we should have 2 3 pi over 4 angles, and they add up to 360 degrees, or 2 pi. Next, we have a side angle side triangle. So we have, you can see it, side angle side triangle. And we also have a side, let's back up a minute. I didn't mean to erase that. We also have a side angle side triangle. So we want to find W. To find W, I'm going to use this side angle side relationship. That's the law of cosines. So we need our calculator again. And to get the length of W, it's going to be 6.9 squared plus 13 squared minus 2 times 6.9 times 13 times the cosine of that angle, 3 pi over 4. Once you get the answer under there, then you're going to take the square root. I'm going to caution you, this is what students do. You cannot find that answer and total it and find that answer. Don't do that. It's going to be wrong. You need to find the entire thing all at one time. And hopefully, if you do it just right, you got 18.533 for your answer. They didn't give us any units. So that W, the magnitude, is 18.533. And then to finish it up, the third thing they want us to do is to find the direction angle. So the direction angle, we can use the law of sines. And the law of sines says the sine of our angle we're looking for divided by 6.9 has to be equal to the sine of 3 pi over 4 divided by W, which was 18.533. So you can find that by doing sine of theta and 6.9 sine 3 pi over 4 divided by 18.533. And I like to do this on my calculator this way. To get the theta answer, if I find sine inverse of that entire expression, 6.9 sine 3 pi over 4 divided by 18.533. If you're careful and do it all at once, you found out that this is your angle measurement, 1/4 of a radian. So our magnitude was 18, roughly 18.5 to the nearest, let's see, round the magnitude to the nearest whole number, so 18.5. Magnitude would be 19. And the radian measure, the direction angle, is 0.26, and we want to round it to the nearest tenth of a radian. So the nearest tenth of a radian would be 0.3. Wow, long lesson, lots of applications. That's the end of vectors for AP Pre-Calc.